Chatbots once relied on single prompts. Today, organizations deploy autonomous multi-agent systems where specialized AI nodes execute workflows without human intervention. This architectural shift changes the nature of compute consumption. A standard query to an AI model is a single transaction. An agentic decision requires a much more complex internal sequence. Every agentic decision executes a minimum of 5 distinct steps: a planning call to determine the approach, a tool selection call, an execution call, a verification call to check the work, and a final response generation call. This sequence forces organizations to make 3 to 10 times more API calls per task compared to standard interactions. API calls are the individual requests sent to the model provider to process data. The MiroFish open-source swarm engine provides a clear baseline for this consumption. A single run of a 1,000-agent swarm operating over 40 rounds burns exactly 80 million tokens. Tokens are the basic units of text processed by an AI model. Running this simulation once a day produces an annual baseline bill of $151,000. Selecting a premium model for that identical daily run in the 2026 pricing landscape balloons the cost to over $1.6 million a year in API costs alone. The hidden, compounding economics of inter-agent coordination have replaced model intelligence as the primary barrier to deploying enterprise AI. To locate exactly where those tokens go, we can deconstruct the 80 million token MiroFish pipeline. This diagram visualizes its 5 sequential stages. Stage 1 is seed ingestion via GraphRag, and Stage 2 is persona generation. GraphRag is an indexing method that extracts entities from text and maps their relationships into a structured knowledge graph. Combined, these initial setup phases consume only 15% of the total token budget. The final 2 phases, variable injection and report generation, account for just 10% of the total cost. These stages remain flat regardless of how many agents are deployed. This leaves interaction rounds as the primary driver of cost. This single phase consumes 75% of the total simulation tokens. During these rounds, 1,000 agents spend 40 consecutive rounds reading others' posts, forming an opinion, and updating internal states. Swarms suffer from a chatter tax that does not exist in single-prompt AI. Standard chatbots use transient memory that is immediately discarded, but swarm context must be preserved. Every piece of localized memory is explicitly serialized into durable text and duplicated across the prompt boundaries of every other agent that needs to read it. This creates the quadratic trap. Context windows do not scale linearly. In round 1, an agent processes a small amount of data. By round 20, the math compounds. Every agent must process the heavily accumulated history of every previous interaction within the simulation. Effective optimization requires ignoring the setup and reporting phases to target interaction rounds. If you do not compress Stage 3, the financial needle does not move. Beyond API billing, massive token volume creates a severe physical infrastructure liability. Parallel agent execution requires the system to hold duplicated memory serializations in RAM, rapidly exhausting standard 8 GB virtual servers. This leads to an out-of-memory kernel panic, a fatal system crash where the operating system kills a process because it has exhausted available RAM. These crashes force the system to retry failed API calls, burning through tokens a second time without producing forward progress. Software engineering often assumes that more compute and more agents naturally yield higher intelligence. Quantitative testing proves this is a fallacy. A 2026 study from Google Research tested 180 agent configurations to map the marginal value of adding agents to a task. Scaling from 1 to 10 agents produces strong gains. Independent perspectives allow the system to cross-reference and verify information. Past 50 agents, the performance curve flattens completely. Information theory suggests that once agents extract all available information from a task, adding more compute hits an intrinsic uncertainty bound. This leads to homogeneous saturation. When agents share the same underlying model and generation pipelines, they produce highly correlated outputs. Running 1,000 identical agents provides 1,000 slight variations of the same opinion, adding infrastructure noise rather than independent signal. System intelligence scales through the diversity of independent information channels rather than the pure volume of agents. Diagnosing the cost trap is the first step. Executing the specific systems engineering required to fix it is the second. This vertical waterfall chart shows the path to optimization. An unoptimized simulation on a frontier reasoning model starts at $800 per run. Technique 1 is batch processing. Shifting non-real-time workloads to asynchronous API endpoints secures an immediate flat provider discount, cutting the cost by 50%. Technique 2 is prompt caching. Reusing the knowledge graph and system rules across the entire swarm prevents processing data fresh for every agent, reducing input costs by up to 55%. Technique 3 is model routing. Because agents interacting on a simulated social feed do not require maximum reasoning capabilities, we can move the massive volume of staged GRE tokens to specialized architectures. Routing to a mixture of experts, or MOE architecture, provides fast, persona-consistent generation at a massive discount. MOE models activate only a fraction of their neural network parameters for any given request. The system forcefully summarizes agent states between rounds, rather than carrying full logs, crushing the quadratic growth of conversation context. This memory flushing technique drops the final cost of the simulation to under $5. Applying these 4 techniques achieves a 99.4% cost reduction, rescuing swarm intelligence from financial impossibility. By 2026, the convergence of open-source capabilities has turned foundational AI models into commoditized assets. Durable advantage no longer exists at the model layer. Enterprise value has moved further up the stack, as shown in this pyramid. A heavily optimized 1,000-agent swarm now costs exactly the same annually as a rudimentary, unoptimized 3-agent framework. Optimized engines like MiroFish function as high-efficiency generators for localized, high-fidelity synthetic data. Organizations use these thousands of modeled outcomes to train their next generation of internal systems. An engineering team capable of running simulations at $5 possesses a 160x advantage over competitors trapped paying naive frontier prices. In the modern era of digital workforces, the competitive moat resides in the optimized infrastructure systems that govern AI intelligence.